Welcome. Thank you for joining. So today we'll introduce our new platform, Sphere. Hopefully at the end of this webinar, you will get a better idea of what it is and what it brings to your workflow as a MODJAW user. And as I said, if you have any questions during the webinar, don't hesitate to write in the chat. Okay. Let's start. Do you see my screen?
Yes.
Okay, so for the webinar, we will explain why Sphere, why we have created this platform that is outside. It's a new software. It's a new online software outside of TWIM software. We'll also show you the two main workflows with Sphere that will cover, let's say, 80% of your cases. There will be always cases that, that are complex edge cases that maybe you won't be able to use with Sphere, but we hope that the two workflows that we're going to show you today are going to cover most of your cases and simplify most of your cases. Of course, we'll show you in live how the platform works so you can see it yourself. And at the end, if you have some question, we can reply. And this webinar will be also available on replay. Okay. So let's start. Why Sphere? So to understand why we launched the platform, I think it's good to come back on the current workflow that exists. So as a user, you record the data with MODJAW device. And then the idea is to send the data to a CAD/CAM software so you can use the jaw motion data for the design part. But with this workflow, what we realized, and maybe that you realized too, is that it requires a lot of clinical knowledge, a lot of manual processing, a lot of time, because you have to go from this raw jaw motion data to a data that your lab, and if you are a lab today, you can understand that the lab can use for the design. So this is why we wanted to simplify these and delete these black boxes that prevents from using this jaw motion data at the design stage. And so you will see Sphere is a platform for MODJAW users, of course, but also for the dental technicians that are working with you on your data. So we will see today the two main workflows using Sphere and how you can integrate Sphere in your workflows using MODJAW and using CAD/CAM software. Usually we'll talk about ExoCAD or 3Shape dental system. So what is Sphere? So we will show you live how it works, but just before showing you the platform, to make it simpler, Sphere is mainly two things. The first one is a collaboration platform. Why collaboration? Because Sphere is an online platform, so you can connect online on any computer. No need to have a computer on which you have TWIM. You can also work on the Mac. So you have access to all of your MODJAW cases online, and you can replay them online and share them with other people that have a Sphere account. Usually it will be between the doctor and the dental technician, and they can collaborate and see the same cases online. So that's why we're talking about this collaboration part. And the other thing that is very important is that for each consultation, you will have access to 4 features in Sphere that we will see later. But the 4 features are crop motion, generate motion, set a new byte, and download data. We will see how it works in a few minutes. So collaboration, as I said, you can connect to your Sphere account online. As a MODJAW user, you don't need to create an account on Sphere. You will have to use the same login that you use with your TWIM software. So no need to create an account. You directly go on Sphere and you can see all of your cases online. And when you click on a case that you recorded on a consultation, you will have access to this collaboration, and you can invite another team member to this consultation. Okay. If you invite someone to the consultation, you will also have access to a chat. Okay, so to have access to the chat, you have to be at least 2 people in the same consultation. And the idea here is to communicate online with the people that have access to the consultation. Okay. And as I said, for each consultation, you can share, you can talk with the chat, and you can use the 4 features that we will see. So with Sphere, there will be 2 main workflows that you can use. The first one is a restorative workflow. It will be the case when you have patients, when you want to gather the data, the dynamic data for the lab. And so the lab can use this data on the design stage easily. And the other workflow is a more advanced one when you will combine TWIM software and Sphere. And to go deeper on the diagnosis and TMD part, usually used as today in your TWIM software for people that have an issue, for symptomatic patients, for TMD patients. Okay, but so yeah, those are the 2 main workflows that we're going to see. Let's go into the first one. As I said, it's a basic one that you can use for restorations, for your asymptomatic patients, where that doesn't include the TMD analysis or patient analysis. So you will start by recording the jaw motion with MODJAW. This is as before. And then once you have this data, this jaw motion data, you will use Sphere mainly for 2 features. The first one is to crop the data. So to go from raw motion data to data that is ready for the lab. And the other feature that you can use in Sphere is set a new byte. The idea is to change the vertical dimension online through Sphere. Once those 2 steps or 1 step is done, you can download all the data from Sphere and import them into a CAD/CAM software. So you will see Sphere can be used as a clinician, or by the dental technician that can collaborate on the case with you. If we go step by step on this workflow, the first part is to record your motion data. So maybe you've seen it, but we have a new release since June with TWIM software. In this new release, there is a list of 6 movements that are really recommended to register all the time. And it's all the more important with Sphere now, because you will see all this motion, all the 6 motion that you will record with TWIM and MODJAW. You will see them in Sphere and can use them in Sphere. So the 6 motion are protrusion, right and left lateral protrusion, open, close, and we've also added speech and chewing. Maybe some of you do not record speech, but usually most of you will record at least the protrusion, lateral protrusion, open, close, chewing. In this workflow, as we said, it's a basic one. Centriculation is optional, but if it's part of your workflow, in any case with MODJAW, it's something that you can, of course, register. But yes, in this workflow, it's optional, and we will see why. So the list of movements to register, you know them: protrusion, left and right lateral protrusion. Here, the idea is to record 2 or 3 times each movement, and it's really important to register each movement correctly, because we realize that some of our users, they register, let's say, protrusion and left and right lateral protrusion in the same motion. And this will be an issue in Sphere, and you will see why. So it's really important to respect the list and to record the correct motion and the correct name of the motion. Speech, usually the protocol is to record the S sound, so to count from 60 to 70, or to ask the patient to say the S sound. And chewing, the idea is to have 1 cycle on the left, at least 1 or 2, and 1 or 2 on the right. So once again, here the idea is to have this data set of motion that you will have from your patient and that you can use and your lab can use for the design. Okay, and usually after this step, you will arrive to this stage in TWIM software when you have all your patients all your movements that are recorded. So we often hear that MODJAW is a digital Facebook, which is true, it is. And since June, we have improved this part as well because we have launched what we call the optimized axis, which is an axis that is automatically calculated from the motion that you recorded with your patient. And this optimized axis will correct the axis that you get from the picking that you do with your patient at the beginning of the protocol. So this allows to correct this axis and to be able to transfer all this data after to your dental technician through Sphere or directly to a file. Okay, so I think it's a really nice new feature that adds on this Facebook part, and that will be automatically here for all of our users. But of course, if some of you calculate the hinge axis on the patients, it's still possible, and we'll see it in the other workflow. Okay, just keep that in mind because this optimized axis or the axis part, we'll see it in Sphere as well. Once you have recorded the motion, you are ready to share to Sphere, to your lab, sorry, through Sphere. So there are two options to share to your lab. Either you click on export button and you will see now there is a Sphere button. If you click on this button, you can share the case to your lab, and on your side, it's done. You have nothing to do, and your lab can have access to the consultation in Sphere. The other option, if you want to continue the consultation and to go directly to Sphere, there is a button in the software in TWIM. If you click on it, it will open the consultation directly in Sphere. Okay, those are the two options when you want to go from TWIM to Sphere. When you open Sphere, there will be two features that you can use. The first one is what we call prop motion. So this feature will select automatically the relevant portion for the design. So you will go from your initial registration of 30 seconds, 40 seconds or more to less than 1 second. And this portion is the portion that the lab can use for the design. So this is done in one click in Sphere, and it can be done by you or by the lab. What we can say about this feature here in crop is that this feature can crop 5 motion. The 5 motion that we can crop in Sphere are protrusion, left and right lateral protrusion, speech, chewing, and that's it. That's the 5. Okay, so let's say if you didn't register them in TWIM, you will not have access to them in Sphere. That's why the list of movements that you register in TWIM first will have an impact on what you have access to in Sphere. Okay, so this is crop, and we will see it also in live during the demo. The other feature that is really interesting is set a new byte. It's something that you can do in TWIM, actually, is to change the vertical dimension. The feature is called OVD shift in TWIM. Here in Sphere, we have improved it a bit because you can open the byte and you have access to a cut view here in Sphere. And we've added some functional parameters for you to check all the time. It's the overbyte and the overjet. And when the software considers that the byte that you are choosing is correct or optimal for the case, the overbyte and overjet will go green, as you can see here. And so you can open from the rotation, or you can open using the motion that you recorded. And if you want to use the motion, then you have access to 2 motions, open, close, and centriculation if you have recorded centriculation. But as you can see, all the time you have this cut view and the 2 indicators, overbyte and overjet, that are automatically calculated. The other option in this set new byte feature is the ability to add an upper and lower mockup if you want to validate the new vertical dimension using a motivational or an aesthetic mockup. Here the idea is to validate functionally the mockup before putting it in the mouth of the patient. Okay, so to do a virtual test of the mockup. So once you have done those two actions, crop motion, set a new byte, you save the data, and you are ready to export it to the lab. Okay, so you click on download, and you can export it to the lab. So for the case, we wanted to show you the platform in live, and we will show you this case that we registered at Denkov Clinic last year with Florine and Maxime. And so the case was done. But what we did with Sphere is that we rerun the case in Sphere to see the results, and we actually got a nice one. Okay. So let's go to the platform. So here's I'm online. This is my account. This is my TWIM account, so I can enter. And I have access to all of my cases that I registered as a clinician. If you are a lab and you connect for the first time in Sphere, because you didn't register any patients, you will have 0. So in this case, the doctor needs to share a case with the lab. Okay, so the lab can see it. So if you see this case here, so once I chosen a consultation, I see it here. Here I see the team that has access to the case. I have the chat here. And in the main area, we have the motion that we recorded with the device that I can replay. Okay. So as you can see here, there are no graphs, no occlusal contacts, because here the idea is not to do an analysis with Sphere, is to work on the data in a simple way. So let's say if we want to crop motion in one click for the case, you can click here. And the software will automatically crop the data for you, and you can find it here. So here is the cropped motion for the case. Crop drawing. Okay. So you will see we have a small portion of the data that can be used by the lab for the design. Okay. If we go on set new bytes, as I showed, you have access to this platform to open the bytes based on the motion that you recorded. Okay. And you have those indicators here. So if you want to set this position as a new byte, you click on save. So what you will have when you go to download is actually the cropped data, the new byte if you have a new one, and you are ready to download. And let's say in this case, I want to download this data for ExoCAD. I can click on it. So I have Gabby with me, who is our dental technician that is working with us at MODJAW, and we wanted to show you how it works in ExoCAD, this data, and how you can open it. Okay.
So let me share my screen. I will try to show you how it works on our side, on the lab part. So these are the files that we get from the download from Sphere. A set of files that we can use in ExoCAD, a dental project that we will need to import to have the data on the correct coordinates with the motion. Upper and lower jaw that will be in the new position that we have set up and saved in the Sphere. And any other additional files that we might have, like a mockup or aesthetic mockup that we did before, or imported there, maybe a photo, a face scan, or even preparations if we have them in the consultation. After importing this data to ExoCAD, what we will have is the case with the position that we have saved. Any additional files, as I said, they will be imported automatically as we have used the dental project that we get from Sphere. From tools, we will have the possibility to load the motion with Joe movement tool. It's a module in Exocad that is called Joe motion import. If you don't have it here in tools, contact your reseller Exocad to be able to activate the module. And when we activate Joe motion, we will have the list of motions that we have from Sphere. Those single lines, trajectories that are usable for a design, because we can't use the whole motion. We need to prepare them first. And Sphere will help us, or the lab part in this area, because we'll have only those trajectories that we can use for our design. We will be able to play motion in Exocad, to be able to analyze the contacts that we have with our design or with our scans. But also, we will be able to adapt in dynamic with them, automatically. To adapt, we will generate virtual imprints in Exocad. So let's say we want to adapt with protrusion, left, right, lateral protrusion. I would select them here and then generate virtual imprints that will generate, Exocad will generate meshes like this that will help us adapt in dynamic. Of course, the first step will be to position the teeth correctly in an aesthetic plane with a photo or a face scan, to do a correct static occlusion with COSA contacts. And after this, we'll be able to adapt in dynamic with the motion. As I said, we will generate this virtual imprint to be able to adapt any intersections or surfaces from our design that would prevent the patient to do the correct movement. Like we see here, we have some intersections with our design, and just by one click with dynamic occlusion in Exocad, we will get rid of any intersections like this. And not only that, but we will be able to, by playing the motion, we'll be able to see and analyze the type of guidance that we create for our patient. Maybe we want a canine guidance, maybe we want to design a group guidance. We can use the cropped motion. And besides doing guidances, we also need to check for interferences. So those contacts that might feel uncomfortable or intervene in our movement. And Exocad has a lot of tools that can help us get rid of this type of contacts, like exclude selected parts and adapt only those areas that we do not need and keep everything that we need as a guidance. And we will need to do this with protrusion, left, right lateral protrusion. With speech, we will verify if we have any contacts that might be uncomfortable for the patient or might create some troubles for our design later on for our bridge and so on. And of course, with chewing to see how our contacts are in the cycle of mastication while we design the interior part of the posterior teeth. This is mainly what we do on the Exocad part with the data that we get not only for MODJAW, but prepared with Sphere. Because if we get everything unprepared, we will not get a precise adaptation, we will not get a precise or a stable static occlusion, and the result will not be optimal.
Yeah, thank you, Gabby. So I don't know if you have any questions for this workflow, but just to sum up, in this workflow, we had a restorative case. The patient had no issues on the occlusion side, on the TMD side. So what we did is that we recorded the motion. We used the cropped motion in Sphere to be able to use the data, the Joe motion data, cropped by Sphere in the design part. Now there is another workflow that is a more advanced one, and that is used by the users who treat patients with issues, TMD issues, occlusion issues, and where you have both to do an analysis and you can still use Sphere, and we will show you how it works. Okay. So second workflow that you can use for diagnosis for TMD patients and for splints. So in this case, you will record the jaw motion with MODJAW as usual. And then once you have recorded, you can use TWIM software to diagnose using all the tools that you have in TWIM, the graphs as well. And one of the key features that our users use in this case is the OVD shift. It's the ability to set a new mandibular position in TWIM, and that you can still do and you can still use. And then what you can do in Sphere is to generate a new set of motion, a new set of envelope of motion for the patient, because those kind of patients are usually a case where you cannot use their motion for the reconstruction. You cannot use the motion for the design. So what is usually done at this stage is diagnosis, but also to use the data that MODJAW provides to set up a virtual articulator. So we'll show you with Sphere how it changes and how we simplify this process. Okay, because instead of using a virtual articulator, now you can use Sphere, or the lab can use Sphere. So if we come back on the movements to record, the list is always the same, the 6 mandatory movements. And in this protocol, we recommend to register in addition centriculation if you don't do it. Because in this case, in this workflow, usually what is done after the recording is the setting of a new mandibular position, and the workflow that is commonly used by our users today is to calculate the hinge axis based on the centriculation of the patient. And then once this hinge axis is calculated, to set a new mandibular position using the OVD shift feature. Okay, so if you are in this case and if you do this in TWIM, but still want to use Sphere, it's possible. Just keep in mind that when you go into Sphere after you did an OVD consultation, when you do an OVD shift in TWIM, it will create a whole new consultation, as you can see here. So for the same patient, you will have actually 2 consultations. One that is the original consultation, and the second one is that where the starting position is the new bite that you've chosen for the patient. When you go into Sphere, make sure that you choose this new consultation before you work on the patient itself, because otherwise this new mandibular position that you've chosen in TWIM won't be seen in Sphere. Okay, so in this case, the patient has an issue and you want to either do a splint or use the data to reconstruct an envelope of motion for the patient. And this can be done in one click in Sphere using the generate. So the idea of generate motion is quite simple. So in one click, we will generate a new ideal envelope of motion for your patient. And you can generate 4 new motions, actually, when you click on this button. It's protrusion, left and right lateral protrusion, and we can even generate a new chewing pattern for the patient. This is very new, and it replaces this protocol that is actually a simulation that you do in a virtual articulator when you had to parameter a virtual articulator using the data from MODJAW or using any data. If you want to add something on it, Gabi, on this case?
This was actually a subject always that we had to discuss with the labs, especially when they are not very accustomed to use the full adjustable articulator. We had to teach them how to program the articulator, how to choose the interior guidance that they need to recreate or to implement to their patient, and what's close to ideal as value. And this can be easily replaced now with the set of motion that we generate in Sphere. So we will be able to use only the jaw motion in Exocad. And not only this, but even for those cases where we have a partial movement that can be used and some that are not, we will not do the switch between the jaw motion and virtual articulator. It will be much simpler to have just one set of motion in the jaw movement tool in Exocad.
Yeah. So once you have done that in Sphere, the idea is to be able to download. So let me show you. I will go back to the same case that I've shown you. Let's say here in this case, if we didn't want to use the motion, but to reconstruct a new one using Sphere, then we click on Generate Motion. And so now the software will generate a new envelope of motion that is ideal for the patient here. And this data, same, can be used by the lab, because once you have generated this new set of motion, you or your lab can download it into Exocad. So what happens in Exocad actually is that you will not use the virtual articulator. You will always use an XML file, but the XML file will be either the cropped motion from Sphere or the generated motion from Sphere. Maybe Gabi, you want to show it in
I can share my screen just to quickly show you another case. This was a case where a flat splint was made on the posterior with anterior guidance. It is a great way to check a new mandibular position, to test drive the anterior guidance that we would like to input in this treatment plan, and to introduce your patient to get accustomed to it. So, like I said, we will use the data that we get from Sphere. We will import the project, and here we'll have the possibility to import motion, the motion that we have generated from tools jaw movement. And we'll have the list of movements that we have generated, and we will be able to use them as we use any motion from MODJAW by playing them and by creating virtual imprints to adapt the splint with the tools that we have as a dynamic adaptation in Exocad.
Yes.
And it will be much simpler without going to the articulator, trying to find the correct values to input for the anterior guidance. We will have already a guide with the generated motion.
Mm-hmm.